For decades, open-source repositories like GitHub operated as quiet digital libraries. Developers shared static building blocks, a front-end framework here, a version manager there, and human reviewers slowly merged them together. But over the last year, those quiet shelves have been swarmed. That ecosystem is currently being hijacked. Instead of humans browsing code, highly autonomous AI bots are constantly roaming through repositories, scanning, writing, and executing scripts entirely on their own. This diagram maps out a tool called Optio. It's an autonomous coding agent. A developer submits a basic task, and the agent provisions an isolated environment, writes the code, and handles the pull request completely without human babysitting. If continuous integration fails, the agent reads the error logs, auto-resumes with new context, and pushes a fix. Beyond individual code fixes, tools like MiroFish are deploying vast, predictive swarm intelligence networks, moving automation into the realm of complex decision-making. This extraction creates a loop where a developer's labor is perpetually harvested to train the tools meant to replace them. It turns the act of sharing code into a direct threat to the person who built it, shifting the open-source community into an era of defensive engineering. This shift toward hyper-automation is being met by an engineering effort to build a digital immune system. The first line of defense focuses on auditing. Engineers are using pen testing tools like PromptFu to red team AI models, purposely attacking the systems to scan for vulnerabilities, expose security holes, and ensure the agents aren't hallucinating dangerous code. But defense also requires personal stealth. Because corporate AI permanently scrapes everything, a developer's identity, their commit history, and every minor bug they fixed is now locked inside a machine's memory. To sever that link, programmers built gitGost, a mechanical solution designed for total identity stripping. This diagram shows how gitGost intercepts a contribution. It strips out the author's name, their email, and all timestamps. Then it masks the user's IP address by routing the push through the Tor network, leaving behind a perfectly anonymous block of code. In an AI-audited world, a permanent public record of minor activity can quickly become a liability. In this context, anonymity is a defensive requirement. Some developers are escalating from passive defense to active warfare by deploying hostile architecture like Miasma to directly attack the scrapers. Developers embed hidden links into their code. Humans see a flat web page, but bots see a clear path. A scanning AI scraper follows the link, dropping into the Miasma trapdoor. Inside, Miasma locks the scraper in an endless cycle, force-feeding it gigabytes of poisoned data. The compute memory required to run Miasma is negligible, yet it can corrupt datasets that cost millions of dollars to compile. Developers have shifted from shielding their repositories to turning public web paths into active minefields for harvesters. We can see this conflict playing out in real time across the entire GitHub ecosystem. The open-source community is reorganizing. Chaotic, open sharing is being replaced by defensive structures that allow humans to dictate the terms of engagement in the AI age. The growth of these tools suggests a future where the code designed to control AI becomes as significant as the models themselves. The viability of this defense depends on the continued iteration and vigilance of the open-source community. As long as the internet's code remains open, developers will continue to invent the traps necessary to keep the machines in check.